Looking at number 9, it says a pilot is flying over a straight highway. He determines the angles of depression to the 2 mileposts are 10 miles apart. So milepost A and milepost B are 10 miles apart. Says the angle of elevation, or sorry, angle of depression to angle A, which would be this measurement here, X, is 31 degrees, and angle Y is 49 degrees. The 2 questions then are find the distance the plane is from point A, and it is from point B. So, or sorry, and that's find the elevation of the plane. So from A, basically it's saying the tip of the nose here, how far would it have to travel to touch A? So we're asking for that distance right there, okay? And then obviously the elevation is going to be that distance there. First thing that I would do here is just start plugging in the information you know. Now, we have to use a little bit of geometry to help out here because they give us these angles of depression. If you remember, an angle of depression from geometry is created from a horizontal, okay, so this dotted line here, this blue dotted line is my horizontal, and our line of sight when we're looking down, okay, so the pilot would be looking down here. So this is angle X. Now, they say, and this is nice, that they say he's flying over a straight highway. The idea here is that we are parallel to the ground, right? Now, the ground is going to have undulations and all that kind of stuff, but in retrospect to what we're doing, those undulations are minimal, so we're going to make the assumption that the ground is a horizontal line, and that's parallel, so then that would make this angle right here the same as X, correct? Okay, and it would make this one here the same as Y. Now, those two zoomed out, so let me see what they were. X was 31 and Y was 49. 31 degrees, 49 degrees. Do we know that this was 10, right? Okay, A to B was 10. The next question is, can I find that distance right there? Let's not use X, let's call it Z. Can I find that dotted red line Z? Okay. Well, what's 31 plus 49? 80. So I'm going to make this angle up here 100. Can I then say that the sine of 100 over 10 is equal to the sine of 49 over Z? And now I knew to use the law of sines because it's a non-right triangle. And right now, obviously, we haven't talked about law of cosines, so law of sines is my only option. And that's really what I always try to do first, is see if the law of sines is applicable. And if it's not, then I know to revert to the law of cosines, which we'll talk about today. Cross multiply, then I get Z sine of 100 is equal to 10 sine of 49. I divide both sides by sine of 100, right? So that should give me Z. Now, just be careful, because if you're a person that says, well, I've been doing that, that's what I got written down, I'm getting a wrong answer, it might be because of your mode, okay? If you're a person that uses this calculator, if this calculator, when you turn it on and off, mine's a little bit different because of my settings, but some of you, when you turn your calculator on every single time, it does this, right? Well, if I go to mode, right now, if it doesn't, like I said, mine's set up a little bit differently. It will revert back to radians, right? Okay, some calculators will do that when you turn them, especially the ones that are on a computer. They automatically revert back to kind of the factory settings when you turn them off, okay? Just make sure you understand that. When you are using one of my classroom calculators, okay, you don't know who had it before you, right? The person that had it before you, their last problem might have been in radians. They've changed it, you grab it, your first problem's in degrees, and you don't change the mode, you're going to be wrong, right? So make sure that you're always paying attention to that. So I'm going to go over to degrees. Got 10 sine of 49 divided by sine of 100. It should give me that 7.66 number. Okay? So now that I know that, the next question is, well, what is the altitude? What is that blue distance right there? Well, if it's an altitude, it's in a right triangle, correct? Okay, or it's a leg of our right triangle. So we'll call that H. Now I'm going to use this triangle over here on the left because I think I know more about that one. Because this Z is now 7.66, right? And you're trying to find H. What is H compared to the 31? What side is it? Opposite. And 7.66 is the hypotenuse. So what uses opposite and hypotenuse? Sine. So I say sine of 31 is equal to H over 7.66. 7.66 sine of 31 is equal to my H. Okay. Something that I think is probably useful to you on your calculator. Like I'm not going to, because I'm going to use this number here. If I round that number, obviously then my H is going to be off a little bit, right? Okay. Now I because of the way WebSign is set up, shouldn't be too big of an issue anywhere. But if I want to be very, very precise with H, or very, very accurate with H, I'm not going to use 7.66. I'm going to do this. I'm going to hit second answer, and then sine of 31. And that means that A and S right there is going to use this full value, right? As many decimal places as it can. And now I get that value there. If I were to use 7.66, I'm going to just kind of see if there's a big difference here or not. Well, I would argue that out to the thousands place is kind of a big difference in a lot of applications. Okay, but in our regards to rounding here, it doesn't matter. No, because both those are going to round to 0.95. So okay, I'll do that one. Okay, so that's law of sines. I want to talk about what we ended with yesterday, and it's the ambiguous case. Because I think if we target the ambiguous case, it gives us a lot of practice with the law of sines, and it gives us obviously a little bit more practice at the hardest type of question within inside the concept of law of sines. So I want to talk about this triangle here, and go through just kind of the setup here. Okay, I talked to you yesterday about the like angle side angle or angle side, angle side side. Those orientation of parts that you can kind of memorize to know. Well, I use law of sines for this one, or I use law of cosines for this one. We're learning today that side 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 and side angle side are the two for law of cosine. Okay. And those are the only two for law of cosine. So if you have something other than those, you got to use law of sines. Does that make sense? And maybe that might be a better way of remembering which law to use or recognizing which law to use. A lot of times, like I said, I think I told you guys yesterday, I don't try to remember those. I just always try to fit the law of sines to my problem. And if I get two variables in it, and I know that law of sines doesn't work, maybe I use law of cosines. But here I think we should be okay. If I go A, would that be B, that be C. And again, the way I set my picture up doesn't matter, okay? Your A, B, and C could be in completely different spots than mine. Your triangle could look completely different than mine. And it's just kind of a graphic organizer, just trying to get us to realize what parts we have and what we need to do. So A, which is 7, would be the side opposite angle A. And B, which is 16, would be over here. Okay. So if we look at this, this is the ambiguous case. This is, if we look at it, the sides are not sandwiched between my angle, right? So the sides are outside my angle, side angle or angle side. The angle is not in between, okay? We call this a non-included angle here, if you remember that from geometry. All right, so we're just going to grab the law of sines. We'll say sine of 30. What should the sine of 30 be over? 7. Is equal to, now what other value up there? I've used 30, I used 7. What do I have to use next? 16. So that's got to be the denominator here, right? what should 16 be paired with here in the numerator? Sine of b. And now it's just cross multiply, right? So I'm going to cross multiply. I get 16 sine of 30 is equal to 7 sine of b. I get 16 sine of 30 over 7 is equal to sine of b, right? Does anybody know what sine of 30 is? We've mentioned this a couple times. You don't have to. You can obviously directly use your calculator, but it's a really nice number. Sine of 30 is 1/2. So what's 16 times 1/2? 8. So this is actually 8/7. Isn't 8/7 a lot neater number, nicer number than 16 sine of 30 over 7? So that's equal to sine of b. Again, if you don't know that right now, it's not a big deal. Now, how do I get b out? Inverse sine. Take inverse sine of both sides, and it's going to look this way. And now that's what I typed in my calculator to find angle b, right? Go ahead and type that in your calculator. Doesn't work. Okay? When I type in, let me see. I think what you guys said yes, I asked this question. If I'm in GeoGebra or Desmos, and I want to use sine inverse or cosine inverse, I just put the word arc out in front. Okay, so it's arc sine is the same thing as sine inverse. And if I take 8 divided by 7, it's going to tell me undefined, right? Okay. Well, here's the reason for that. If I were to graph the arc sine function, that's the arc sine function. Okay. What's its domain between? What are the x values that thing is defined for? -1 to 1. 8 divided by 7 is bigger than 1, right? It's outside that domain. It's not an input value that's going to yield an output. Okay? So I don't get anything back. Okay? If you look at that, essentially what's happening with the, I've got it in regards to radians on the y-axis, pi over 4 to pi over 2, that kind of thing. But how many degrees is pi over 2? 90 degrees. So the sine inverse is only going to give you numbers back in degrees that are between -90 degrees and +90 degrees. Okay, those are things that we'll come back and there's entire sections and chapters devoted to that logic, that understanding, and dealing with that stuff. But I do think it's important for you to see, well, what's my calculator? Why does it say in domain error? That's the reason. Okay, now how does that tie into the ambiguous case? Well. And what's it telling us about the ambiguous case? If I've got an angle that was 30 degrees, I've got a side length opposite it that was 7, right? And the other side length was 16. Which one? This one's got to be 16, right? Yeah. Opposite was 7. Okay, so I've got to use that dotted line. That's part of the 30-degree angle, right? That's a ray for that 30-degree angle. So that's going to be a ray or a side of my triangle, correct? Obviously, the 16 is the side of my triangle. The 7 has to be a side of my triangle. But does that 7, does that ever intersect this side down here that I have to use as part of that 30-degree angle? It never touches, right? Okay. So does it ever create, and I've got this highlighted, but does it ever create a triangle? No. Okay. So that is the ambiguous case in which you have no solutions. Okay. And hopefully that makes sense. You just got something back on your calculator that says we don't have a number for this, so how can you go any farther, right? Or further. Okay. So that means no solution, nothing, no triangle exists from the information being provided. Okay. Now, in respect to the types of questions that you see a lot of times that do deal with the ambiguous case, usually you see one solution or two solutions. The no solution one doesn't occur very often. Maybe out of like 20 of these, you might see that once. Okay. The one solution case, I'm not going to do one today. We did one yesterday with it. The one solution case is kind of this idea that 7 kind of has to touch just one time. Does that make sense? Okay, meaning that if I were to draw that arc right there, essentially the circle that is going to be created by this segment, okay, it would be what to that side there, it would be tangent to that side there, okay? Kind of a way, maybe, do you guys talk about this stuff at all in physics? Okay, sometimes they use that tangent idea, that concept to visualize that in physics. All right, so here we got another triangle. Changed the A from 7 to 10. Okay. Again, I don't care the setup of the picture. I'm gonna make this point B over here. So this would be 16. Let's make this A here. No, sorry, I messed that up. I don't want to do it that way. So I want to model what I've got set up in GeoGebra here in a minute. So let's make this be A. So that would be 30. This would be 10. And yeah, let's make this 16. So this would be angle B. And this would be C. Okay, so we're going to go through this and use the law of sines. Okay, it's a non-right triangle. Use the law of sines, and I want to be able to find angle C and angle B. Okay. Now, which angle am I going to find first, though? B. Okay. So I'm going to say sine of A, which is 30 degrees, over 10, is equal to sine of B over 16, right? Cross multiply, I get 16 sine of 30 equals 10 sine of B. Divide both sides by 10. And now what would I do? Sine inverse, right? Again, I'll just leave it as this, but you could change that to 8 up top if you want to. So you get 8 over 10, which is 0.8. Is 0.8 in the domain of the sine inverse? Yes. So that's my angle B. Okay. So now I'm going to take my calculator, figure out what that is. Sure I'm in the right mode. Sine inverse. I'll just type in 0.8. Gives me that number right there, 53.13 degrees. Okay. Now, just kind of bear with me here. If that's 53, and I'm going to write approximately 53.13 degrees. Okay. I want to then find angle C, right? Okay. And this is going to happen to you. Here you can't find angle C using law of sines again, but there will be situations where maybe you have options. Maybe you have the ability to use the law of sines a second time, or maybe later today we use law of cosines once, and then you can use the law of sines to find an angle, and then you can use the law of sines to find a second angle. Well, using the law of sines to find that second angle is stupid, because you already have, what will happen, you'll have two angles already in the triangle. Don't we have other techniques that are going to allow me to find that third angle a lot quicker? Yeah. So be thoughtful. That's what I think is a huge aspect of mathematics, is being thoughtful of all your options you have to find something. Don't be robotic and just say, well, this is the section we're in, we're using law of sines, so I got to continually use law of sines all the time. Use all of your previous knowledge to make things a little bit simpler. Okay? So finding angle C here, we're going to have to take 180 minus value, right? So it's the second answer. And then it would be minus 30. And it gives me 96.86. 96.87. How are you going around that? Okay? Okay, so in the last class we kind of went through the practice of saying, well, if that's 96.87, okay, when I go through and try to solve this triangle, I try to solve for this length C down here. Okay, I want to find all 6 parts, right? When I do that, because the 53.13 was rounded, the 96.87 is rounded. When I solve for C, is C going to be accurate when I use those values? No. Okay, but we can use our technology if we're creative, if we're thoughtful. We should be able to use our technology so there's absolutely no rounding. Okay, I'm going to write the rounded value in my handwriting, but then when I get to my calculator, I'm actually going to use the calculator's full decimal places. Is that okay with everybody? Okay. So when I'll find C, I would say what sine? Which angle is best to use? 30 or 53.13? 30. That's exact, right? Sine of 30 over 10 is equal to sine of, now if I'm going to find C, I got to use this 96.87 number, right? Over C. I don't like that green. If I cross multiply and solve for, I'm going to do this all at once, but solving for C here, I think you guys can do this algebra. We would have 10 sine of 96.87 every like 10 minutes. 96.87 divided by sine of 30, right? Or if you want to use it as a 1/2, that's fine. Okay. So we're good there, right? That's going to give me C. Let's kind of go walk through and talk about how I would use my calculator so that I'm not rounding the numbers here. Okay. Couple different ways you could do this. I can just use the A and S key if I wanted to, because the previous answer is that 96.869896765 number, right? Okay. Or if you are a person that says, well, I like to use this STO button. Okay, I'm going to store it, and maybe I just say I'm going to store it as A. Actually, let's use alpha. It doesn't matter. You could use X if you want to. But I store it. So now every time my calculator sees C typed in, it's going to spit back 96.87 in that spot, right? So let's use a substitution technique. So I'm going to take 10 sine of C then, and we'll divide that then by sine of 30. And it's going to give me that number there. And that's the length of C. That's 19.85. And now what's nice about that number is that I am accurate out to that last 6. Okay? I don't know if that last 6 is truly a 6. I don't know if it's been rounded up. So if it should be a 5 and the number after it is bigger than 5, or if it's actually a 6 and the number after it is less than 5. Okay? I do not know that because of the capacities of this calculator, but at least here, I know that this is accurate. Does that make sense to everybody? Okay. Now let's kind of make the comparison. I already used 10 sine, and let's just go 96.87 instead of this whole value here, or a whole set of decimal places. Divide by sine of 30. So I'm just going to put 0.5 here. Gives me that number. Are those two numbers fall? Right here is where we start seeing them differ, right? Okay, so this one is accurate up to that 0. Not bad, right? Pretty good rounding there. But depending on your application of this stuff, if you're working for NASA, you probably don't want to use that bottom number, right? Okay, if you're going to Lowe's to get some lumber, you're probably okay using that, but you're probably using 20 instead of 19.8, right? So you just understand your application of this stuff to understand rules on rounding on how to do it. Okay, I think it's also important, just trying to give you ideas, just kind of thoughtfulness in regards to WebAssign. If WebAssign tells me to write my answer with 2 decimal places or 3 decimal places, that means when I'm rounding inside my problem, I better be using more than 2 or 3 decimal places, right? Okay, because of that the impact of that rounding error. Okay. So that is one solution. We have solved that triangle. Okay, so we currently have a triangle that has a side length of 10, 16, and 19 point, whatever that was, 8 something. We got a 30-degree angle, 96.87-degree angle, and a 53.13-degree angle. Is that okay with everyone? Now we got to check to see if the ambiguous case is present, okay, or the multiple solution part of the ambiguous case is present. So we talked about yesterday that the way we do that, okay, we solve the number right there first, right? That was what this B was. What is always an option instead of that number, but what is always the option that angle could also be? It's supplement. So I got to take that number and subtract it from 180, right? Okay, so I'm going to go back up to that number, subtract 180 from it. Now my sign is wrong, but it'd be 126.87, right? So this angle here, this angle B, I'm just going to draw kind of a smaller triangle down here. So this would be 30. Now my triangle obviously is not to scale. This would be 126.87. Does that leave me enough room in regards to the triangle angle sum theorem to figure out what angle C could be? Okay. Angle C is going to end up being, let's see here, it's minus 30 away from that again, and now let's add 180 into that. That should give me 23.13. So angle C could be 23, yes, 23.13 degrees. This would be 16, this would be 10. We still need to find C, right? Now I'm not going to go through this part with you, but actually we will. Let's find that C. But let's be smart about it, because we've already done 95% of the work to find C. Did this formula here find C for me? Am I still going to have a sine of 30 paired with 10? Okay. Am I still going to have a side C that I've got to use, right? Okay, so the sine of 30